How you going, guys? Curtis from Cutting Edge Engineering. Today's job, we have a H-link from a 23-tonne excavator has come in for repair. This H-link is off a Kobelco excavator. What the H-link does is connect the bucket cylinder down to the bucket. This is what controls the crowding of the bucket. We actually have an excavator in the yard, so let's show you what the H-link does and where it goes. That's the H-link. So this originally came in for line boring. The bores are very, very worn out on the bottom position of the H-link. But H-links on all different brands of excavators are made from a really unusual material that can be very difficult to weld. So if you were to attempt to weld this with a standard wire or a standard electrode, it goes rock solid and you can't machine it, or it doesn't stick at all. The only way to really find out what material you're trying to repair is to do a couple of weld tests on it and see if you can file the weld. If you can't file it, you're probably not going to be able to machine it. And this is one of those cases where I've tried high nickel and nothing wants to stick to this H-link. So welding it up really isn't an option. The next option would be we would oversize the hole and put a sleeve in there. That also has its own problems. Because of the amount of material we would have to remove to put a sleeve in there, we would be losing a lot of the structure of the bottom of the H-link. So it would end up leading to cracking and a failure at some stage. So the customer did go and contact aftermarket parts suppliers to try and find a replacement H-link. Although they are all very similar for that size and series of machine, they are slightly different. The length of them changes, the width of them, and the pin diameters. He couldn't find anything new or used, so the only option we have left is to build a new one. So that's what we're going to do. Righto guys, so you might notice I look a little bit different. That's because I've had a shave. It has been a couple of days since we've started. I got an emergency call to go out on site and do some repairs. Now we're back here in the workshop and we can get back onto building our H-link. So we've got all of our material for our new H-link. We have plasma cut Bislloy 80 grade plates. We have a 40mm internal plate and 25mm side plates. They will make up the internal structure, which then tie into the bosses. For the bosses that the pins and bushes run in, it is a 1045 180 by 70mm hollow bar. The hollow bar is a lot thicker than it needs to be, but I couldn't get the size I wanted, so we just go undersized on the ID and we bore it out to suit the bushes. The bigger piece of hollow bar, it will connect the H-link to the quick hitch, and the two shorter pieces will connect the H-link to the bucket cylinder and the dog bones. We also have 4 new bushes that will be fitted to the H-link after it's been completed. So we've got a lot of machining and fabrication to do on this job. What we're going to get started on is the hollow bar, because without it we can't do anything else. So we're going to get the big piece set up in the lathe and start machining. Because we've got a lot of boring to do on this piece of material, I am going to support it with a steady rest. So I need to open the ID up to 93mm to give a grease clearance around the 90mm pin. I then need to bore both ends to suit our bushes. So to do that, I've set it up in the 3-jaw chuck and the 3-jaw tailstock chuck. I'll then cut a steady band, set up the steady on the hollow bar, and then I can start boring it. Now that I've got it set up in the steady rest, I'm going to face the end of the hollow bar. I'm going to machine a true surface, so when I flip it around in the 3-jaw to machine the other side, I've got a nice true concentric area to clamp onto with the jaws. So to bore out the ID, I'm going to be using our 50mm Moncula anti-vibe bar. I'm going to be taking out the ID 5mm at a time until I get to my 93mm, which will give me the clearance around my pin. The bar's not going to go the whole length, so I will have to turn the job around once I complete the machining on this end and do it on the other end as well. Now I've got the ID bored to suit the pin. I need to bore the end to suit the bushing, but I'm not going to machine it to its finished size because it is going to shrink and probably pull itself out of shape when I do the welding. So I'll leave 2mm material in there and I can line bore that to size after it's been completed. Now that we've got this side machined, we're going to flip it around and do the same to the other end. So we've got the ID board. Before I go and change the setup to turn the OD, I'm going to get the other two pieces of hollow bar up to the same stage. For these smaller pieces of hollow bar, we only need to bore out the ID to within 2 mil of the finished size of the bush. Righto, so we've got all of the boring done on our pieces of hollow bar. What I need to do now is change the jaws on the chuck so I can grab the parts from the inside. So I often see comments come up about why don't I use a drill or an impact gun for speeding up winding the chuck jaws in and out. So that is something you will never see me do to a chuck. That is a really lazy practice. Although chucks are extremely robust, the scroll insides are quite delicate. If you get a piece of swarf trapped in your scroll, which it's going to happen, and you start using an impact driver to try and wind the jaws out and the piece of swarf is trapped in there, you can damage the scroll, and if you can't get replacement parts, you may have to throw the chuck in the bin. If you wind them out by hand, you can feel when you do run into any resistance. It does take a little bit longer, but I know I'm not going to damage the pinion or the scroll or any part of the chuck. For those who don't know, the chuck jaws are numbered. So you have 1, 2, and 3, and you have corresponding slots in your chuck that they are to go into. That's how they were manufactured, in that orientation, and then they would have been machined or ground to size to keep the tolerance for the chuck. If you are to mix them up and not put them in their correct orientation, you're going to end up with tolerance issues. So I'm going to turn down the OD of the 2 smaller bits of hollow bar first. I am going to use a cone center or a pipe center just to hold that into the chuck. I do need to remove about 15 mil of material off the outside diameter, so let's get stuck into it. So all the turning's done on our 2 smaller pieces of hollow bar. What I still need to do to them is drill and tap a hole for a grease fitting. But now we're going to get onto our larger piece of hollow bar. We just need to take a skim off the OD and then we can do all the finer details on it. So we do need to relieve the center section in order to fit up with our plate we've had cut. And we also need to do a bit more detail on the ends for an O-ring seal. So now we've got the OD cleaned up, I need to machine a relief through the center, and that is to suit our 40mm piece of plate to be welded onto the hollow bar. The relief is not super critical, it just needs to match up with the plate we've had cut. Rather than go through the effort of working out angles and setting the top slide and whatnot, we're just going to do this by eye. Right, so really happy with how that plate fits in there. I don't need to do a great deal of work to the plate in order to fine tune it. What I need to do now is machine basically a big chamfer on each end of the hollow bar, and what that is for is to hold an O-ring. And the O-ring is used to try and keep dirt and debris out of that moving joint.
Whoa! Hey?
Righto, so that's all the turning completed on our bosses. What I need to do now is drill and tap the holes for the grease to be fed into the bushes. So the two shorter bosses, they need to be drilled, tapped and countersunk down below the surface height. But the big boss that goes down to the quick hitch, it only needs to be drilled and tapped. That can't be counterbored because of the wall thickness. So once it is completed, I will machine up a shroud to protect the grease fitting and it will be welded in place. So I decided to buy some indexable 90-degree countersinking bits. All of my high-speed steel bits don't like harder materials, and it tends to wear out the cutting edge, or it drags the back of the tool across the job and makes a bit of a mess. So the ones I'm trialing, they are an indexable 90-degree countersinking bit. You have a two-sided insert, and it has carbide that has been brazed into the back of the tool, so it doesn't actually pick up on the job you're cutting on. And because they are carbide, you can actually cut induction hard chrome with them without any trouble at all. And I'm really happy with how these have worked out. So that's all the machining done for our hollow bars for now. We still do need to line bore those to suit our bushes, but we'll do that after the H-link has been completed. What I need to do now is get the plates prepped so we can put this thing together. So let's take it all over to the welding area.
Bring me. Alright, come on.
So we're going to start with beveling our center plate. I am going to put a very heavy bevel around the outside edge where I do need to do the welding. I do have a hole on the inside and a scallop on the back side of the plate. I'll do a light bevel on them just to make them look more appealing and make sure there's no sharp edges. So there's a couple of methods you could use to bevel a plate to put a weld prep on it. You could use oxy and LPG or oxy and acetylene. You could even use a plasma. But because I want this to look really nice once it's done, we're going to use this. So this is a BM-18 beveling machine. It is basically a 9-inch grinder with a speed controller on it and a 45-degree beveling head. It runs from 1,800 up to 5,850 RPM. And with this milling head, you can cut up to an 18mm wide bevel. You can adjust the depth of the bevel by undoing the little screw on the front and winding the faceplate in or out. So the inserts are replaceable, and you can also turn them around. They are very expensive, so it is best to just take it very easy on these. They do the work, you just don't need to push them. You can buy different heads for it to cut different shaped bevels. You can buy radius cutters. A 45-degree cutter was best suited for the work that I do, but the milling head and the grinder itself was a lot of money. So I used to bevel all of my plates using an oxy torch, and then I'd have to go back and clean them up with a grinder. The problem with that is it heats up the plate so much you can't touch it for a pretty good period of time. Where with the beveling machine, you can cut all of your bevels, it doesn't heat up the part, you don't need to go back and grind anything. The only thing you need to deal with are all the baby needles it makes, and it is extremely noisy. So all the plates are prepped. The beveling machine made really quick work of them. They're not even hot, but it does make a bloody big mess. So the bevels come out really nicely. I'm pretty happy with those. You could take them in a single pass if you really wanted to, but it does destroy the carbide inserts. So I just take my time with it. I do it in a couple of passes, end up with a really clean bevel, and I don't end up destroying the inserts. So we've got our plates prepped, got our hollow bars machined. What I need to do now is weld this together, line bore the bosses to suit our bushes, install the new bushes, and we need to give it a coat of paint, but you'll have to stay tuned for part 2. Thanks for watching.
Yep.
There you go. Oh wait, hold on straight.
Where's your level?
So that's all machining.
I just need to get comfortable because I think we'll be here a while.
Now that that's finished, we'll get all... Fuck. So we've got our plates prepped, we've got our bosses machined. Oh fuck, where are we going with that? So what this is, what the fuck is it? Right, so now that I've got it set up, now that I've got the now that we've got the steady rest set up, last go, ready?
Yeah.
Right, so as...
Wow.
Amazing. I'm just gonna stop you, bitch, because you fucking fucked it up.
Please. Oh, wow.
No, train came fuck me up.
Nah, that didn't do it.
That did it.
Who's that?
Think we have... fuck up, man.
Wow.
Oh, that ID's out of whack. Man.
Wow. What was that?
Cracking the fucking screen.
But you can still use it.
Yeah. It's just another fucking set of calipers down.
Jesus.
For fuck's sake.
They look cool though. Does it need a little bit more, or is that good?
That's pretty bloody good.
Where is he? Not over there. Where is he? Drop. Wait, sit. Drop it. I must drop it. Or not.